Lesson 23, continuing on question 5. The part C says what volume of acid is needed to reach the half equivalence point where pH is equal to pKa. Well, this is VEQ 1/2 and half of 54, which we determined up here. So VEQ, 1/2 would be 27 milliliters. So easy peasy. What is the pH after 50 milliliters of acid is added? Gonna need some more space. Okay. So in this case, it's before equilibrium. So when we have a weak and a strong, this is where we're gonna have a buffer at play. So this is before equivalence point. And so really what I'm looking to solve for is my habub. Okay, so I need to know my new value of ammonia and ammonium. And to do that, I have to take into account how many moles I started with, how many moles have reacted, and divide them by the new volumes of my things that have been added together. So I'm starting off, and I have 0.054 moles of ammonia. I know that because I calculated that already. I've added 50 milliliters of a 1 molar HCl, so that's going to give me 0.05 moles of HCl. The ammonia is in excess. All of the HCl is going to be consumed to produce ammonium. So all of this is going to become ammonium by consuming the ammonia. So to solve for the NH3, I'm going to subtract my excess reagent and my limiting reagent to get how many moles are left over. And then I'm going to divide that by my new volume, which I had started with 90. And now I've added, and this should be milliliters. And I've added 50 milliliters, which gives me 140 milliliters total, which gives me a new molarity of ammonia of 0.086. So this is my base. Now my ammonium, 100% comes from the HCl that I've added. So I'm going to take all of the moles of HCl, and they are going to become my moles of ammonium. And I'm going to divide that by the new volume that the ammonium is in, and that's going to give me a molarity of 0.357. And this is my habub. So it's habub. And now I'm going to plug it into my Henderson-Hasselbalch equation that's written in the terms of pKb and pOH. Now the thing is, I have a KB value, right? So I'm going to go ahead and, shoot, I don't think I wrote it down on my paper. Let's see. I'm going to take the negative log of the 1.8 times 10 to the 5th plus the log of my HB plus and my base, my just B. Okay? And I'm going to solve for the pOH, which pOH is going to be the 4.74 plus my negative log, make sure I do all these numbers right, 0.357 divided by that number's not right. 0.357 divided by 0.0286, and take the log of that. This is going to be 1. We'll do 10. And that's going to give me a pOH of 5.84. To make that into pH, I'm going to subtract 14 and 5.84. You may get slightly different numbers depending on how you round, and that's okay because I'm not going to give you say a pH is equal to 8.16, and or is it equal to 8.15, or is it equal to 8.14. I'm not going to make them that close that if you made a different rounding error or a rounding choice than I did, that you're going to get it wrong. Okay, so it gives us a pH of 8.16, which still makes sense because my ammonia is in excess, so we would expect the pH to still be basic.